Hello, I'm Kevin Worrall. I'm from Scotland. I was brought up in Glasgow. I was brought up in the south side of Glasgow, and I'm currently working at the University of Glasgow. So, engineering. I, I'm an interesting engineer in that I do lots of different little things. My main areas of engineering are space engineering. So that is making things work in space, whether that be in orbit around planet Earth or on the surface of Mars. My other major area is kind of robotics, and that's either mobile robots that run around a house or robotic arms that are able to move and transfer something from A to B, or maybe you put a scanner at the end in a hospital and it scans your body. So that's the kind of engineering I'm doing, is kind of robotics in space. Which is, I mean, it's pretty cool to be able to sit there and say that to you, that these are the areas of engineering I do. To kind of drill down a wee bit more into it, basically I look at programming. How do we get the robot to move from A to B? So we program the robot and we allow it to recalculate how it moves from getting from one bit to the other bit. So that's kind of my main area. The other areas is actually building the motors and how we can control the motors and the electronics, and kind of putting it all together so it does actually carry out that task. Now, at the moment, we've got quite a lot of different wee projects on, and some of them are amazing. As some of you may well know, we are currently exploring Mars. We've got rovers running around on Mars looking at different bits of rock. We've had a couple of little drills on Mars that have been able to drill down, a few centimetres on Mars. One of the major projects I'm looking at this moment in time is a drill that will look at drilling 20 metres into the surface of Mars. Now, no one's attempted this before. We now know why no one's attempted this before, but at this moment in time, we're building a prototype in the lab here in Glasgow that will hopefully lead to a fully functional 20-metre drill on Mars. The reason we're interested in drilling 20 metres is Mars hasn't got much of an atmosphere, so the surface of Mars gets baked by the sun, it gets hit by a lot of radiation from the sun, which means that if there was any signs of life, or if anything existed on the surface, it's probably dormant or dead, or it's kind of not, it's not going to tell us anything. However, if we're able to drill beyond 5 metres, 10 metres, hitting that 20-metre target, there could be things on there that haven't been affected by the sun, and that's why they're so interested. However, it's a phenomenal engineering challenge. How do you get something to drill 20 metres when you can't just keep on putting a tube in, like they do in the oil industry? They just move a tube and they put another tube in the hole, they put another tube in the hole. We can't do that. They won't allow us to go to Mars. They won't pay us to do it. But what we can do is we can roll up material, and we can try and get this material to go down and use that as a drill. So that's something we've got on at Glasgow at the moment. Now, connected to that particular project is another amazing project that we've got on, which is an Antarctic Ice Drill. So very much like the 20-metre drill we've also been asked to do one for Antarctica. And the idea is the British Antarctic Survey, who go out there and they've got bases out there and they monitor the ice flows, and they've done a lot of great science over the years. They can cut ice. They're brilliant at cutting ice. They can do 400 metres of ice in, I think it's 3 days is the current record. However, the minute it hits rock, their ice drill breaks. And they realised that we had a Martian drill that might be able to cut rock. So the idea is we're involved in a project which will cut down through the ice 400 metres. They'll then take their drill out and they'll put our Martian drill at the end of it. It'll go down and it'll take out 30 centimetres of rock. Why this is important? So this 30 centimetres of rock potentially has not seen sunlight in over 100,000 years. What that means is that rock has got historical measurements of what the Earth was like over 100,000 years ago. And there are scientists they'll be able to take that rock and analyse it and tell you how much carbon dioxide was in the atmosphere, how much sunlight they saw, and all these other different things. That will allow us to potentially predict what the climate's going to do in future years. So yes, we're not involved in that science, but they cannot do the science without our drill. It's that simple. They've been after a drill that can recover rock 400, 500 metres below the surface of Antarctica, but they've never been able to do it. We've now got a drill sitting there gathering dust, and we've made the connection. So hopefully, all going well in the next couple of years, that drill will be going out into Antarctica, and we'll be able to get this pristine rock that's never seen sunlight, or hasn't seen sunlight for 100,000 years. So really quite amazing projects that we're currently doing at the University of Glasgow, but they're driven by engineering. You have to know a wee bit about mechanical engineering, a wee bit about electronic engineering. You need to know how to program. So the standard question that's always asked is, how did you get into engineering? I mean, what path led me to these kind of amazing projects that we're doing? And the simple answer has always been robots. Always been fascinated. When I was a child, I was always fascinated with robots, how they moved, how they worked, how did you get them to move? And that kind of love of robots, I wanted to know how they worked. So I kind of studied at school the kind of subjects that I thought I would need to know, like maths, physics, engineering type of subjects. I then went on to university and kind of did engineering as my kind of main degree. And then it just so happened I got the opportunity to continue that within the space industry, which just opened up this whole concept of drills in space, satellites in space, robots basically beyond the Earth. And it was just from that fascination with robots in the first place. How did they move from A to B? And all of a sudden I'm doing these great projects. So kind of going on from there, we've got these amazing drill projects, but other things we kind of are looking at now, we're expanding into medical robotics. So we've got all this knowledge about, we can control robots on Mars, we can drill, we can control satellites. So we're now taking a step back and going, well, how can we help more people? So we're currently looking at areas involving medical robotics. How can we take the knowledge that we've gained and actually start looking at making it work in hospitals, to help surgeons, to help doctors, just to help anyone in a hospital that might need it, whether that be taking a patient from one room to another room, or whether it be carrying out the operation that the person's doing. So that's kind of where we're going with the research we've been doing. Now, circus. Obviously, you're all really interested in this crazy idea about how did we get from engineering and circus, and what are the connections? And one of the major connections between circus and engineering is learning from your mistakes. It's one of the major elements that we learned doing some of the circus skills you were learning. That was what we learned as well. To learn to juggle, you had to understand the ball's not going to land in your hand sometimes. So you had to keep on repeating and getting it right and practicing, dropping the ball. You made a mistake, it doesn't matter. You learn from that mistake and move on. And certainly in my engineering career, that is mostly how I've learned, by making a mistake. Brilliant example was the very first drill we ever did. We built this beautiful drill, we turned it on, and we almost destroyed about £5,000 worth of equipment. Now, the reason for that was we didn't understand how the drill and the rock were going to interact with each other. We had to make that mistake. We had to turn it on and make the mistake. We made the mistake, we learned so much from it, and we were able to kind of move on. So going back to the juggling, we dropped the ball, but what we then did was pick it up and throw it again, and we caught it. The second time we drilled, we caught it. We did it, we drilled, we only drilled a couple of centimetres, but that was better than not drilling. So we drilled a couple of centimetres and we then learned, right, we threw up the next ball, can we go deeper? We couldn't go deeper at all. And then we changed some parameters, we changed the drill bit, And then all of a sudden we were doing 30 centimetres within a couple of weeks from that initial couple of mistakes that we made. So the connection between engineering and circus for me is that practice, keeping on practicing and keeping on making the mistakes, because it's the mistakes that we're learning from.